Hello guys, and welcome to Atomic Structure and Nomenclature Part 2. In today's video we're going to be covering the polyatomic ions. Polyatomic um, ions, right? So what are polyatomic ions? Polyatomic ions are charged molecules composed of two or more elements. When polyatomic ions have an oxygen within it, they are known as polyatomic oxoanions. As we can see here from the previous uh, video, or the first part of atomic structure and nomenclature, we see the word anion, which means that these polyatomic oxoanions will have a negative charge. Right? Now, how do we name these polyatomic ions or oxoanions, and how do we know where they are? So, we typically like to follow the rule of 7. Where does the 7 come from, or what is the rule of 7? The rule of 7 simply states that we see this 7-like structure here on the top, right? Ranging from boron, carbon, nitrogen, as well as chlorine, bromine, and iodine. Now, the reason there is no fluorine or there is no oxygen is because fluorine cannot become a polyatomic ion, and there was already oxygens within these polyatomic oxoanions, so we couldn't add more. Now, we see this 7-like formation of these other elements. And within that 7, we see these other elements such as phosphorus and sulfur, which are right here. Right. And a good way, now what does this reference of the 7 and those outside of the 7 have to do with the rule, or how to name them? So typically found within this 7, the 7-like structure, we have a reference number of 3 oxygens. Right? Oxygens. That means that in the base form of how a polyatomic ion would be named, or the common name used for most polyatomic ions for these elements, they all contain 3 oxygens to be considered in their base form or in their common form. Now, these outside of the 7 typically have a reference number of 4 oxygens, right? 4 oxygens, meaning that the common name for phosphorus with an oxoanion or an oxygen, it has to have 4 oxygens in order to be considered basic or common, as well as sulfur, selenium, and arsenic. Now, how do we name them, or what is the base name of these polyatomic ions? So we see that if they do have their reference number, they have their common name or their basic name, and the basic name is simply changing the suffix to 8, right? 8, which we use when in reference to the number of oxygens, right? Number of oxygens. Now, what do I mean by this? Meaning that, for example, let's take chlorine. Chlorine, right? So chlorine has a reference number of 3 oxygens for its base form. That becomes ClO3. Now, the reference number tells us that it's going to end with the suffix 8. Now, chlorine simply becomes chlorate. Right? Now, an interesting how does the anion part, or the negative charge, come into this this rule, or the naming of polyatomic ions? So we see that each element has its own distinct, or each polyatomic ion has its own distinct charge, right? So we see that the column of chlorine and bromine and iodine, they all tend to have this -1 charge here, that I'm going to be underlining in blue, right? This -1 charge. Now, we see that nitrogen also has a -1 charge, but then we see that carbon has a -2, and then boron has a -3. Now, these within the 7, these elements, these polyatomic ions, phosphorus and arsenic tend to have a -3 charge, while sulfide sulfur and selenium have a -2 charge, right? So when writing polyatomic ions in their chemical structure form, we need to write the charge, right? So in this case, chlorate has a -1 charge, or chlorine has a -1 charge. So we usually like write the same um, charge when we're writing it as a polyatomic oxo anion, right? Now, let's take into consideration one of these other elements within the 7. We have, for example, we have sulfur. Sulfur has a reference number of 4 oxygens since it's outside of the 7 structure, and it has SO4. Now, the typical charge for sulfur is a -2, so we would simply write the -2 charge, right? So we have sulfur, right? But we change the sulfur suffix to 8 because it has the correct number or the reference number of oxygens within it. So sulfur becomes sulfate, right? Now, this comes in handy when naming all of the base forms of all of these different elements. But what happens if we change the number of oxygens? What happens if it comes with 2 oxygens instead of 3, or 5 instead of 4? Well, I'm glad you asked. When we change to let's say less number of less number of oxygens, less number of oxygens, when change to less number of oxygens, we see that here, let me change the color to white so it can be a little bit better to see. When you have less number of oxygens, we change the suffix to ite, not ate, but ite, right? Ite. So let's take these 2 examples of chlorate and sulfate. So let's say chlorine now has 2 oxygens instead of those 3 reference number oxygens that it usually has. Now, ClO2 becomes, instead of chlorate, will now become chlorite, right? Let me change this, chlorite, right? Chlorite. So now we have chloride. Now, what happens to the charge when we change the oxygen numbers within this molecule, within the polyatomic ion? So the charge we saw over here is -1, and it will still continue to be -1. The charge never changes. When we add or subtract oxygens to the polyatomic ion, the charge always remains the same. Now, what about sulfate, for example? Sulfate has 4 oxygens as its reference number of oxygens. But if it loses 1 oxygen, sorry, I made a mistake here. It would be a loss of 1 oxygen. Let me clarify that. That'd be a loss of 1 oxygen. Loss of 1 oxygen. We name this to ite, right? So let's take this. Let's go back to example sulfate. Sulfate has 8 because it has its reference number of 4 oxygens. But in this case, it loses 1 oxygen, so we now have SO3. But remember that the charge still remains the same. So instead of sulfate, this would be known or changed to sulfite. Sulfite. Now, let's say it loses another oxygen, right? Let's say it's a loss of 2 oxygens. Loss of 2 oxygens from its base form, right? Loss of 2 oxygens from its base form. There's base reference number of 3 or 4, depending on which molecule we're looking at. So the loss of 2 oxygens, since we are losing oxygens, we still have the suffix ite, right? still has the suffix "ite," but now we add the prefix hypo. Hypo. Right? So let's take, for example, chlorite. Right? Let's say chlorite loses another oxygen, or chlorate loses two oxygens. Now we saw that in the original, chlorate has uh, 3 oxygens to its reference number. So if it loses 2 oxygens, it would just be ClO. Now remember, we still have to write that -1 charge. So this 1 oxygen now mixed with this chlorine will, instead of being known as chlorite, it will be known as, let me change these colors, maybe better, hypochlorite. Hypochlorite. Right. Now that is because it lost those two oxygens, right? Hypochlorite. Now let's take into consideration sulfate. Sulfate was had a reference number of 4 oxygens, but now that it lost 2 oxygens, it would just be SO2. Now remember, we still keep the charge as the charge never changes. So now this element, or this polyatomic ion, will now be known as hypo sulfite. Hyposulfite. Right. Now this all comes nice and neat when we know that it loses, it has a loss of oxygens, right? So the loss of 1 oxygen, we simply change the suffix from "ate" to "ite," and the loss of 2 oxygens, we add the prefix hypo, and we still keep the same suffix of loss for "ite," right? So we get chlorate to chlorite to hypochlorite. Now let's say we actually gain some oxygens. In this case, a gain of oxygens will have the suffix per, right? And we'll still have and we'll now still have the suffix ate, right? So this is when we gain 1 oxygen. Gain 1 oxygen, right? So let's take into consideration the same examples. Let's use chlorine, right? So chlorine, when it's in its base form, when it just has its reference number, is chlorate, and it has 3 oxygens. But now we see that chlorine has 1 more oxygen. So instead of the 3 oxygens, it will now have 4 oxygens, right? So we still know that it has a -1 charge. Now, how would this be named? So since we gained 1 oxygen, we would add the per prefix, keep the base name of chlorine, chlor, and change the suffix to ate. So now this will be known as perchlorate. Now, likewise with sulfur, we see that sulfur's reference number is 4, so its common name is sulfate. But now we have 1 more oxygen, meaning that it's now SO5, and it still has that -2 charge, right? So now sulfate gains that 1 oxygen and will now be called with the base name of sulfur, and change the suffix to ate. Right? So this will be known as persulfate. Right? So to recap really quickly, is the common name known for the number of reference oxygens that it commonly has will have the suffix ate. So chlorine will have 3 oxygens, becomes chlorate, and sulfur becomes sulfate when it's paired up with its 4 oxygens or its base form of oxygens, right? When we lose one oxygen, the suffix changes to "ite", changing chlorate to chlorite or sulfate to sulfite. Then we have the loss of two oxygens, which still keeps the same loss of one oxygen, "ite", but then adds the prefix "hypo", meaning below. So you can think about it as below the loss of one oxygen, meaning hypochlorite or hyposulfite. And now we see that when there's a gain of one oxygen, we add the prefix, the Latin prefix "per", meaning through or very. So there's very much of chlorate, so there's a perchlorate or persulfate, right? So let's do an example really quickly. Now, how could we find out the name of this element, right? Let's say we have, mm, let's say we have mm, P PO2, right? With a -3 charge, since it has phosphorus. Now we know that phosphate, uh, has a reference number of 4 oxygens, right? Phosphate would be PO4 with a -3 charge. Now we lost when we lose one oxygen, it becomes phosphite. And we know this by making sure that it loses one electron or one oxygen, and we have still that -3 charge. So this is phosphite. But now we see that this has 2 oxygens, meaning that it lost a total of 2 oxygens. So we add the prefix hypo now, since it's below 1 and below the loss of 1. So now we have hypophosphite. Right? And this is how we can name these different polyatomic ions, right? So I hope you guys learned something today, and next video and the final video for atomic structure and nomenclature will be going on how to naming acids and bases. And I hope you guys learned something, and if you guys have any questions, please feel free to comment down below and share it and like it as you please. Thank you guys, and I hope you guys have a great day.